Hey everyone, so today we are going to talk about normal distribution, one of the very important distribution in statistics, or I would say machine learning or data science, or in general whenever you are playing with data, normal distribution will come into picture in one way or the other. Okay, it's very important. So like I still remember when I was having a talk with one of the CEOs of one of the company, he said every day they receive around 8 to 10 million lines of data. Now obviously humanly you can't just play with those millions of lines. Okay, you have to interpret the data, but how will you do? Will you read line by line? No. So once you're a data scientist or the person who's playing with data, the first thing is like you do the cleaning of data. There are techniques. You do cleaning of data, you do sorting of data, and after few steps you do visualization of data. And when you do visualization, this will come into picture somehow. Okay, so that's why it is important to study normal distribution and its properties. Now it's a long topic, so what I'm going to do is today I'm only going to concentrate on the theory part. In the next lecture I will talk about standard distribution, and in the next lecture I will take some examples and how to use tables and those things. So let us try to understand the concept first. Okay, now enough of the introduction. Now in this case your x will be a continuous random variable, and let f of x be its probability density function. Now whatever terms I'm going to use, all these things I have recorded earlier. The link for the playlist you can find in the description. Okay, so my x is a continuous random variable and f of x is the probability density function. Now when you plot this function, and if the curve comes like this, the bell-shaped curve, if the curve of the probability density function comes like this, the bell-shaped curve, then we say that x follows normal distribution. Okay, and many times this bell-shaped curve is also called as a normal curve, or it is also called as a Gaussian curve. And because of that Gaussian curve, it is also called as many times Gaussian distribution. Okay, why Gaussian curve? Because in mathematics, I don't know whether you have seen it or not. In mathematics, there is a function f of x which is a e raised to minus bx square, where a and b you can take to be positive constants. This is called as a Gauss function. Okay, and when you try to plot the graph for this function, it will be a bell-shaped curve. Let us try to see this. For example, for simplicity, let me take f of x to be e raised to minus x square by 2. Now here a is 1, b is 1 by 2. How does the graph of this function looks like? One of the best ways, go to Google, just type e raised to minus x square by 2 graph, you will get the graph. Okay, that's one thing. But if you are a mathematics student, if you have studied mathematics subject, and if you want to know what is going in the software, whenever you are plotting the graph, what is happening at the back end, like it's the complete calculus. Okay, so maybe, I mean, it involves the concepts of critical points, increasing, decreasing of a function, concavity, asymptotes, and all those things. Using those concepts, one can plot this graph. Okay, so you don't need software if you know these concepts. You just give a try to find critical points, inflection points, and see whether you are getting such type of curve. If you are not getting, let me know. I will record a separate lecture, calculus and normal distribution. Okay, so that I will do later, but let me give an idea for this. So what is the graph for x square by 2? We know x square is a parabola, so x square by 2 will also be a parabola. What will be minus of x square by 2? Minus means it will go down, reflect along the x-axis. Now we are taking this curve power to the exponential. Okay, so how the graph will look like? That's what the question is. Now see, e is always positive. This is always positive. So graph is always positive. So your curve will always lie in the upper half plane. That's the first thing to observe. Now what is the value? When x is 0, the value of the graph is 1. This will just get shifted at the height 1. That's first thing to observe. As x goes to plus infinity or minus infinity, this is always positive. So this will be e raised to minus infinity. So therefore which is 0. So as it goes towards plus or minus infinity, the graph will goes towards 0. And you can see you're getting a bell-shaped curve. Now here actually you may ask those questions which I said just few seconds back. Like once you have at 0 it is taking the value 1, e raised to 0 is 1. And then as x goes to plus minus infinity, it goes to 0. It approaches to x-axis. So like x-axis is the asymptote. Now you may say, why you have drawn that bell shaped? Why you have not drawn a cusp like this? Or why not you have drawn something like this? Why that specific curve? So that's where the calculus comes into picture. But okay, maybe in the next lecture I will spend some more time on calculus. But yeah, so that's the rough idea. X square by 2 minus x square by 2. When you take exponential, you get this type of curve. You can verify from the online softwares. So you get a bell-shaped curve. Now, question is this your probability density function? See, what is the condition for a function to be a probability density function? It should be non-negative, which is true in this case. It is non-negative. But is the integration 1? Is the integration of this function 1? Let us try to find integration minus infinity to infinity e raised to minus x square by 2 dx. Now here you will need the concept of gamma function. If you don't recall, then if you don't need, you can ignore the proof. Just see the last line what I'm going to write. And if you're interested for more details, you can see my lecture on gamma function. So what does the gamma function says? It says gamma of a alpha number is nothing but 0 to infinity e raised to minus t raised to alpha minus 1 dt. I hope I have written it correct. But yeah, this is what the definition is, where alpha can be any real number except 0, minus 1, minus 2 and so on. Now, if I want to bring into this gamma function form, first of all, I should have 0 to infinity. Now, here you can say it's an even function. Even function means what? When you replace x by minus x, this is minus x square, which is again x square. So, when you're replacing x by minus x, you are getting the same function. Therefore, this is an even function. And whenever you have even function, minus infinity to infinity becomes 2 times 0 to infinity e raised to minus x square by 2 dx. Okay, now here I want to bring into this form. So what substitution you will choose? You observe, here you are having x square by 2, here you are having t. So what you do is you substitute your x square by 2 is equal to t. So what you get? X dx equals dt. So that integration becomes 2 times, when x is 0, your t is 0. When x is infinity, your t is also infinity. So limits are same. E raised to minus t. What is your dx? It is dt upon x. Dt upon x. But what is your x? It is square root of 2t. Okay, so I can take out square root of 2 outside. So I have root 2 integration 0 to infinity t raised to minus half e raised to minus t dt. Now what alpha should I take so that I get this answer? So if you observe, if I take alpha equal to half, half minus 1 is minus half. So this is root 2 as it is. This is nothing but gamma of minus half. You put alpha equal to half, plus half. You put alpha equal to half, you get this integral. So this is nothing but gamma of half. But what is gamma of half? Again, you can see that lecture. So this is nothing but root 2. What is gamma of half? It is root pi. So root 2 into root pi is square root of 2 pi. So integral of this function is square root of 2 pi. It is not 1. So if I want to make this a probability density function, so what modification should I do for this function? What modification should I do for this function? So what you do is you define your PDF to be, you divide by 1 by root 2 pi. So 1 upon square root of 2 pi e raised to minus x square by 2. So when you take this as your PDF, if you take this as a function, it will act as a PDF. Because when you integrate, this is a constant. Integration of this is square root of 2 pi. Square root 2 pi gets cancelled. You get 1 as an answer. So that's why this 1 upon square root of 2 pi comes into picture. Many books I have seen, they simply define like this. And people wonder why this 1 upon root 2 pi comes into picture. Okay, so now I have given you a good answer. Okay, so now this is the probability density function. Now if you try to draw the curve, what is the maximum value your function will take? When your x is 0, it is 1 upon square root of 2 pi. And again when x goes to infinity and minus infinity, this will approach towards 0. So you are getting a bell-shaped curve. Now here you can observe the graph is symmetric about x equal to 0 line. It is symmetric about x equal to 0 line. So normal distribution means it's always symmetric about a line. Which line? I will come to it. But as if now you can observe it is symmetric about x equal to 0 line. Is there something special about x equal to 0 for this scenario? This line? Yes. If you try to find the expected value of the random variable, expectation of x, it will come out to be 0. What is the formula? Expectation of x, integration minus infinity to infinity, x f of x. So x into f of x. What is f of x? Upon root 2 pi e raised to minus x square by 2 dx. Now one way to solve is by integration by parts if you want to solve, or another way you put x square by 2 st and again do the substitution and all those things. But if you know little bit of odd and even function, you can observe this is an odd function. 1 upon square root of 2 pi will come outside, minus infinity to infinity, x e raised to minus x square by 2 dx. Now this is an even function, your x is an odd function, product of odd and even is always odd, and integration minus a to a of an odd function is always 0. So this complete thing is an odd function, so therefore its minus infinity to infinity integration is always 0. If you don't, if this is difficult to digest, you can see my lecture on odd and even function as well, or you can try to solve by earlier hints which I gave you. Okay, so for this PDF, the expectation of x comes out to be 0. Okay, and in general we will see the bell-shaped curve is always symmetric about its mean. In this case, it is symmetric about x equal to 0 line. That means it is symmetric about the mean. Now you may ask, you have found the mean, what about the variance? So let us try to find the variance. Okay, so I have done most of the calculations just to save your time. So this is the PDF and your expectation is 0. We want to find the variance. We have seen earlier that variance of a random variable is expectation of x square minus expectation of x the whole square. But expectation of x is 0. So this is 0 square. So this is minus 0. So no need to write. So variance of x is nothing but expectation of x square in this case. What is expectation of x square? It is x square into f of x. So x square into f of x. You can take out this root of 2 pi outside. Now again you can see x square is even function. This is even function. So product is even function. So this will be 2 times 0 to infinity of this quantity. Now again here you put x square by 2st. So you have x dx equal to dt. Now when x is 0, my t is 0. When x is infinity, t is infinity. So this will be 0 to infinity, e raised to minus t. Now I have x square dx. So I am writing x square as x into x. And then 1x dx is dt. So only 1x will remain. Okay. Or you can simply replace dx by dt upon x. 1x and 1x will be cancelled. Here I am having 2 which I am writing root 2 into root 2. So 1 root 2 will get cancelled. Only 1 root 2 will remain. Okay. Now what is my x? If you observe, what is your x? Your x is nothing but square root of 2t. So this is square root of 2t. So root 2 will again come outside. What is root 2 into root 2? You get 2 and this is nothing but root t. That means t raised to half. So this is 2 upon root pi. What is this? Now again recall the concept of gamma function. What is gamma of alpha? Integration 0 to infinity e raised to minus t dt, t raised to alpha minus 1. Now what alpha you should take so that you get t raised to half? So you should take 1.5, that means 3 by 2. So this is nothing but gamma of 3 by 2. Again just see my lecture on gamma function. This is 2 upon root pi and this will come out to be root pi upon 2. Okay, I have done that calculation over here. So please see that lecture if you are not convinced. Root pi 2. Therefore the variance comes out to be 1. So what can you say about the standard deviation? It is plus minus 1. Okay, so why I have calculated this variance and variance and the standard deviation, because now you can see what does normal distribution tells us. Now it is symmetric about 0. So this is the curve you are having. This is 1 and minus 1. This is 2 and minus 2. This is 3 and minus 3. It's symmetric. So when I find the probability for mod x less equal 1, that means from minus 1 less equal x less equal 1. What is the answer? It is the area, because probability is nothing but this area under the curve, right? This constitute a lot. This constitute around 68.26% of the data. This one standard deviation. Okay, that's why people say look into one standard deviation interval, or look for the interval from -1 to 1. Okay, so that means this part contains 34.13%, 34.13% is symmetric. If you take probability from -2 to 2, this much area, then this whole together constitutes 95.44% of the data. Okay, so this whole thing constitutes, so that much amount of data is centered or it's near the mean. Okay, and if I take from -3 to 3, that means 3 standard deviation interval, it takes around, like from here, it takes around 99.74 or something. That's what I think, it's 99.74, but yeah. So within 3 standard deviation, 99% or almost 100% of the data is accumulated over here. So that's why people, whenever they want to study the data, they concentrate over this. So no need to go over from -infinity to +infinity. When you do that, you get 100%, but from -3 to 3, you get 99.74% out of the 100%. So like you can see here, hardly few of the data is left. That's why people always talk about the standard deviation. In the next lecture, we will see z-score concept. So that's the same thing. Okay, so that's why one should plot and see how the normal comes out to be. Okay, even while deciding the marks, many people know this, but still, while deciding what should be the passing mark and all, we do plot the normal curve. Whenever you are playing with the heights of a trees or a human being or weight, again the normal distribution comes into picture. Whenever you have a huge data, you always play with the normal distribution. It always helps you. Okay, now you may ask, what if the mean is not 0 or the variance is not ±1? Mean is mu and variance is sigma square. Then what function should I take so that it will behave like a PDF or you will get a bell-shaped curve? Well, the answer is you take 1 upon square root of 2 pi into sigma. Make sure you write carefully. Many people just write 2 pi sigma like, and while checking the paper, then people argue whether this is inside or outside. Okay, so if you want to take this inside, write sigma square. If you don't want to give square root, you give a proper dot in between or give a proper space. Okay, I have observed in past that marks do get cut. Okay, because it's not students' mistake, they are in hurry, so they write fatafat, they write fast. But yeah, and this is nothing but e raised to minus, you translate by mean, x minus mu square upon twice the sigma square. Now you can see in earlier case your sigma square was 1, so sigma square is 1, so it was divided by 2, your mean was 0, and here it was mod sigma. Some people also write mod sigma, but it's, yeah, as if now it's okay. If you want to be precise, you can, it depends upon the author. Some people write mod sigma here because sigma can be plus or minus 1, right? That's what we got in earlier case. But some people they write sigma itself. So depending upon which textbook you are using, you use that as a definition. Okay, let me write sigma because I just want to give you the idea. I am not authoring any book, so I should not worried about that. Now here also, if you observe, when your x is mu, what is the maximum value you get? When your x is mu, this part is 1, you get, this is what, 1 upon square root of 2 pi into sigma. This is the maximum value it will take. It will come out to be the maximum value because again calculus comes into picture. It's a critical point and the double derivative is positive and all those things. Okay, and again if you try to draw, because of the inflection points and concavity and all those things, this is the graph you get. Again you will say it is symmetric about x equal to mu line. So the normal distribution is always symmetric about its mean. Okay, and then second thing, your sigma square is the variance. Okay, so again like there it was plus minus 1, so here it will be mu plus sigma and mu minus sigma. So this is one standard deviation interval. You can always compare with the earlier case. Mu was 0, 0, minus 1. So minus 1 and 1. Then what is the two standard deviation, or within 2 standard deviation interval? Then 3 standard deviation interval. And your 99.74% of the data will lie over here. Okay, so this is one thing. Just homework problem for you. Try to see that mu minus sigma and mu plus sigma will come out to be the inflection point. That's why concave up and concave down. I couldn't resist talking about the calculus, but yeah, anyways. So that's the hint for you. So anyways, coming back to statistics, yeah, 99.74% of the data lies over here. Okay. Now another thing you can observe here is, see, when your variance is small, you're taking a square, so it's again further small. So the ratio will be large because denominator is smaller, so the ratio will be larger. So this quantity will be smaller because you're taking minus over here, so this will be smaller. So whenever your variance is small, this quantity is small, that means the data will be clustered. It will be clustered more around the mean. When your sigma will be large, that means large standard deviation, variance will be large, therefore the ratio will be small, but you are taking negative, so this quantity will be large. So the data will be more spread out towards the mean, and that's the reason. Okay, so when variance is small, or indirectly your standard deviation is small, data is more clustered towards the mean, and when the variance is large, or indirectly your standard deviation is large, data is more spread out away from, or it's spread out away, or it's spread out from the mean, or it is spread away from the mean. Okay, so there's the small observation by looking over here. Now again, what will be the mean and the variance and the standard deviation? Well, in this case, when you try to find the mean, it comes out to be mu. Okay, so instead of finding mean or the expectation of x, let us find expectation of x minus mu. I will tell you why. What is this? Integration minus infinity to infinity x minus mu into f of x. It is root of, let me write 1 upon square root of 2 pi outside. And one more thing, you can try to see that this integration comes out to be 1. So I have not done that calculation here. You try to do this calculation. While doing the calculation, the hint is you can do change of variable. You let z is equal to x minus mu upon sigma. So you have e raised to minus z square by 2. And then again further you can put z square by 2 as t. Again gamma function will come into picture and you will get the answer. Okay, if I do here again 10 more minutes will be taken. So that's the hint for you. Try to prove that this is a PDF. It is non-negative. That's not a problem. The concern is integration is 1. So try to do that. Now here what do you have? So this comes outside. So this is sigma over here into e raised to minus 1 by 2 x minus mu upon sigma whole square. Now here you can observe I am getting x minus mu upon sigma, x minus mu upon sigma. And that's why I took expectation of x minus mu. Now if I call z to be this, 1 upon root 2 pi integration minus infinity to infinity z e raised to minus 1 by 2 z square. So if z is x minus mu upon sigma, what is my dz? It is 1 upon sigma into dx. This is 0, it's a constant. So what is dx? Sigma dz. It is sigma is again a constant, dz. Now again the same thing, this is an even function, this is an odd function, so product is odd function, and therefore integration minus infinity to infinity is 0. But if you recall my earlier lecture, what do we have? This is 0, but what is expectation of x minus mu? It is expectation of x minus expectation of mu. But again there we have seen, what is expectation of constant? It is constant only, and you take mu to that side, so expectation of x comes out to be mu. So when you take this as a PDF, your expectation comes out to be mu. Okay, and now you want to find the variance. Now how do you find the variance for this case? Again the same formula that we used for the earlier case. What was the formula? So again you find variance of x minus mu. So what is this? This is expectation of x minus mu the whole square minus expectation of x minus mu the whole square. But this came out to be 0, so no need to write this. So what is this? 1 upon root 2 pi, let me write it outside, and sigma as well. Integration minus infinity to infinity x minus mu the whole square into e raised to minus of x minus mu the whole square upon 2 sigma square dx. Now you can again use the same technique, put z equal to x minus mu upon sigma, and then you do that substitution. And see, we have seen earlier that variance of x minus mu is same as variance of x. When you translate, variance doesn't change. So these two things are same, and when you try to solve this again by the same technique, if you don't get, ask me in the comment section, I will give you hint, or I will give you hint right now. You put z equal to x minus mu upon sigma. So, and try to solve that thing, you will get the answer to be sigma square. So for this PDF, mu is the mean and sigma square is the variance, and that's why people usually write x follows normal distribution with mean mu and sigma square, because for this PDF x is a random variable. What other parameters we should know? We should know sigma and mean. So mean and variance we should know. That's why people say like this. So in earlier case, our x follows normal of 0 1, because mean was 1 and your variance was, sorry, mean was 0 and the variance was 1. So these are the notations that you will always see whenever you are playing with the normal distribution. Okay, so I think enough of the things I have told you today. In the next lecture, we will talk something more about normal distribution. And in today's lecture, if you have any doubt, you can ask me in the comment section. And if everything is clear, then do not forget to like, share and subscribe. Thank you.